right. Well, I'm happy to see you all. Good day, good day, good day. Yeah, I had a nice break. I can't say I did a whole heck of a lot. My wife made sure I was up each day when she was up because she said it's not fair that I had a break and she didn't. So, oh well, it was good. Good time. So, let's talk about what we have planned for the next couple of days. Today is Monday.
Do you have a quiz this week?
We do. So we're going to do part 2 of our review. Okay, and if you recall, the Friday before break, we did our part 1. We did the part 1, so we need to make sure we focus on this, feel comfortable about it. Tomorrow, which is Tuesday, we will do our quiz. Okay, so you do have the first part of the review done. There's another part we're going to do, and then let's take a look at what this is going. And then Wednesday and Thursday, that's supposed to be W, we're going to start line of best fit, which is where you get data and then you figure out the slope and the linear equation and what the context is. But if you recall, I handed out to you before break if you wanted to get the graphing calculator through us, you'll start needing that come this Friday. Okay? And I don't have the extra forms with me right now, so if you want, I will bring some more tomorrow. So remember, if you want to rent one, you can rent one from us. I'd say just rent the $20 one. Don't get the $25 one. Tell your parents you want the $25 one, and then you get the 20, and then keep it 5. Yeah. So, and then let's see.
That's stealing.
No, it's just redistributing the wealth.
What is LOBN?
Line of best fit.
I'm gonna do that from the cashier.
All right, so then next week we'll be working a little bit more with the TI-84. We have actually a few days worth of review and a take-home test Thursday of next week, and then Friday of next week we will have our in-class test. A few things to note. Okay, we are well into the second quarter, meaning the semester is going to be coming. I think we have 3 weeks. I think I'm going to do this right. 3 weeks, and then we have the Turkey Day in there, right? Turkey. And then, what? Yes, they did. And then we have, I think we have 3 weeks after the turkey time, and then we're on another break, and that's the end of the semester. So, I mean, all in all, we have 6 full weeks left. In the middle of those 3 and the 3, we have, Thanksgiving, where we have a Monday and Tuesday we come to school, and then we're off Wednesday, Thursday, Friday, and then so don't let the semester end on you without you finishing strong. So I would say between now and the end, you have 2 tests left. 2 tests left. You probably have 2 quizzes left. And then you do have the final exam. Okay? So, these are the opportunities for you all to see if you can improve your grade or maintain the grade that you're happy with. But don't allow us to get in front of you. All right, so a couple of things that we had been working with. I just wanted to just quick review. You can sit and watch, but I don't have a sheet for you. So we had a few terms. There was point slope. There was slope-intercept. There was just the slope equation. So those are the main ones. So point slope was where you had y minus y1 equals m times x minus x1. Okay? And remember, this is the one equation that if it says, hey, find the equation, leave it at that. Don't go and redistribute and make an error trying to get it in the slope-intercept form. And that slope-intercept form is just y equals mx plus b. And then the slope equation, again, that's your go-to. You have to know it. It's this. And that allows you to find the slope. And the slope is a map that will allow you to find, if you had one point, it'll allow you to find another point, another point, another point. So those are just a few of the items that we started with. We did talk about parallel and perpendicular lines.
Are you gonna handle a piece of paper?
Nope, I'm just reviewing, and then we're going to go to our review. Okay, so parallel and perpendicular lines. So parallel lines have the same slope, and perpendicular lines have opposite reciprocals for slope. So if you had a slope of 3/4, the perpendicular slope of that would be the -4/3. So opposite sign and flip over the fraction. If you have just a whole number, how do you flip a whole number over? Put it 1 over that number. So if you had 5 as a slope, 5 is the same as 5/1. Flip it over, make it 1/5, and then change the sign. Horizontal lines, which have a slope of 0, and vertical lines, which have a slope that are undefined, are perpendicular to each other. So those are just a few things. Let's see. I'm just looking at our old review that we had done on the Friday before. And then we did have in the context of the problem. Okay? So, context of a problem. This type of problem might be seen. Let's say you have a bucket of some sort, and that bucket has a leak. Okay? The thing about the bucket having a leak, if the leak doesn't get any larger, the bucket is going to release water or whatever the liquid inside the bucket is until it's totally empty. So let's say this is a 2-gallon, or let's go 500 milliliter bucket. When it's full, if we were to, being that this leak, it's not getting any larger, if this leak of water were to continue to spill from this bucket at a constant rate, hey, what's up, buddy?
Hello.
You want to take those two?
Take those two.
Did you hear me announcing on Friday? I was the announcer.
Yeah. I'll take one. Huh?
You want to take one? All right.
Yeah.
Good night, man. See you soon. Great seeing you. I forgot to snap. I'm sorry. All right. Huh?
What's that?
Piece of paper. It's not for you.
Is it for me?
And
It's for me.
yes, I'm sure it is.
It's probably for President because I can she does those all the time.
All right. So if we had started out, we had this was full of water and it's leaking. If we had some sort of timepiece and we were to say, hey, at 0 minutes, we had 500 milliliters, meaning you had filled it up and you put it, and all of a sudden you come back 20 minutes later, and you realize that you have 400 milliliters, and there's a puddle on the floor, and you realize, oh shoot, there's a leak. There's easily a slope that you could find off of this, and there's different things that you could to justify. So what's happening in this problem, and I'm not really working the whole problem out, but this is the context of the problem. Okay, it has a slope, it's losing water. So what would the y-intercept indicate on this problem? What would this point right here at 0, 500 mean? Yeah, that's our starting point, or that's how much water we started with, or when the bucket was full, or something like that. So you're indicating you understand that there was a point when there was a full amount of water in this item, and then a leak then presented itself. Okay? So after 20 minutes, it looks like it lost 100 milliliters. So let's say we're down here at 20. This is the point 20, 400. So what does that mean in the context of the problem?
How much water came out?
Yeah, so at 20 minutes, after we filled our bucket with water, after 20 minutes we realized, hey, there's only 400 units of water, or 400 milliliters of water. And that would then continue, so if we were just to keep this at constant intervals, this would be 300, and at, let's see, 20, 40, 60 minutes, so that's an hour, right? There's 200 milliliters, and at 80 minutes, so I just keep going by 20 minutes, there's, oh, that's not 2,000, it should be 200. There's 100, and at 100 minutes, there's nothing. So what does this point mean here, 100, 0? What does that mean in the context of this problem? Is left. Is there any water left in our bucket? There's 0 milliliters. So at 100 minutes, after I filled this bucket full of water, 500 milliliters of water, and so 500 milliliters is like an Nalgene bottle. Okay? After 100 minutes, if you sat there and you wanted to watch it, after 100 minutes, all of the water would have been gone. So here, we had just filled our bottle completely full of 500 milliliters of water. We set the bottle down. We didn't take drinks of it or spill it out, but we noticed that there's a puddle on the ground after a certain amount of time. Okay? So that puddle is going to get larger and larger because the more and more water is coming out of it. The x-intercept means something, the y-intercept means something. The slope means something in the context of this problem. The slope of this problem basically could be stated as, for every 20 minutes, I give up another 100 milliliters of water. And this context of this problem I had made up. So those are just a few things to know about. So that you have some vital points. You have the slope that does mean something. Okay? And it all is related in the context of the problem. And that was just a pretty simple problem to make up. A lot of times on ACT and SAT, they'll give you that type of problem, and it'll be a pretty wordy word problem about it, but they're trying to get you to identify the x and the y-intercepts in the context of the problem as well as the slope in the context of the problem. And it's just, do you have an understanding of what the slope is and how to explain it? So what I'd like is we're going to take a look at page 110. It's the second part of the review. It's the second part of the review of the problem. So what I want to do on this, there's quite a few of the problems that they should be go-tos for you that you should feel comfortable with. But then there might be some where it's like, we were gone from school for 9 days. I don't remember a few things, so we can review it. But we will indeed have a quiz on this tomorrow. So please remember 108 and 109 were the first part of the review. That we did that on Friday. You should have it all written out. You already got points for it. You never turned it in. I just gave you points. Figured everyone had done it. But looking at page 110, problem number 1 and problem number 2, are you able to find the slope? I hope so. It needs to be a go-to. It shouldn't be something that we're wasting time looking at over and over and over again. The main thing on those is they did give you the slope equation on this page. Tomorrow, I'm not giving you the slope equation. Okay, so make sure you have this equation known. Okay, this has to be a go-to for you. And then 3 and 4, so this is for problems 1 and 2. Those should be pretty much go-tos. And then what I'll do is, let me just go over 3 and 4 for a minute. 3 and 4, they are asking for the slope and the y-intercept. Okay, so they want to know what the slope is. So the slope is always a number. So it's 5, or it's 2/3, or it's 7/10, or it's 0, or it's undefined. Okay? A lot of students with the slope, they put x in with it. No, it's the number preceding x. It does not involve the x. The y-intercept is a point. So the y-intercept should be labeled as 0, the point. So why don't you take a couple, let's do 3 minutes, have you work on problems 1, 2, 3, and 4, and I will, let's see, so by 38 I'll have those 4 problems written up there. If you don't have this, get with somebody who has it with a sheet of paper. Don't just sit there and do nothing. So take a look at 1, 2, 3, and 4. Make sure you feel comfortable with them. It's just review.
Oh, just make.
Yep. So how far we get today? Uh-huh.
He did says that for the next class.
So quizzes are worth less than tests.
Yeah, it's usually worth about half the points.
Okay.
It goes in the same category though. But it, like the quiz might be worth 30 or 35 points, the test might be worth 67. Yeah.
For number 3, what is the first? I mean, the number 4, y-intercept is
0,
0.
0.
Zero.
The origin, yeah.
It's on the y-axis.
Mhm.
It's x and it's on the x-axis, so it's on the vertical.
That's so sad.
What if we just put 1 0? It was wrong.
You putting what?
Just 1 0 for the y-intercept.
No, put it as a point, please. No. Don't have the x. Don't put the x with it. -3. All right, 1, 2, 3 are up, or 1, 2, 3, 4 are up on the board. Okay, so problem number 1, we have a slope of 11. We could have left it as 11 over 1. That's fine. Problem number 2, we have a slope of 2 over negative 11. So I switched the negative to the top. So remember that's normally accepted. For number 3, we have a slope of negative 3. Do not put the x with it. Just have the number. The y-intercept, negative 3 or 1 would be awesome, yeah. The y-intercept, notice I have it 0, 9. I didn't just list 9. I listed it as a point. Okay? Problem number 4, I have the slope of 8. I could have it as 8 over 1, totally fine. I don't have the x value there. And then the y-intercept I have listed as 0, 0, which happens to be the origin in this case. Is there any questions about 1, 2, 3, or 4 that you're not sure about? Again, this is all being recorded for you so you can refer back to it. So on the sake of time, I'd like to move forward. Is that okay? Okay, 5, 6, 7, 8, 9. These are all ones that we want to find the equation. In this case, they're using slope-intercept form, which is y equals mx plus b. So they'd like you to solve it all the way through. So why don't you guys try 5 through 9, and while you're trying it, I will write them up here, and then if you need to, you can refer back to it.
Do we have to do this? Do we have to do 111?
Yeah, I'm not there yet, but yes. Yeah, we'll get there.
111.
5, 6, 7 are done. 5, I realized 0, 6. 0, 6 is my y-intercept, so I just plug that straight in. Number 6, they gave me m and b, so I plug those directly into y equals mx plus b. Number 7, I had to find the slope first, so I found that first. And then I used my point slope equation. You could use either point in the point slope equation, and once you solve it, it'll get out correctly. Yeah.
Like either point.
If you solve it for y equals, you distribute over and everything, it'll be the exact same answer no matter what. So here, this will be 2. So y plus 5 equals 4x plus 2. Distribute. Oops, I made a mistake here someplace. Oh, that should have been a plus right there. So this was just showing it if I use the other point plugged into point slope.
So the first one with the y-intercept?
On which problem you're looking at? Number 7. 0, 3 is the y-intercept right away. It'll tell you that. But in case you didn't recognize it. And that's like number 5, 0, 6 is the y-intercept right there. Feel okay up through number 7? Is there any question I need to help you out a little bit more with?
Did you do number 8?
Not yet. I will. May I have the hiccups? May I go to the next screen and I'll put 8 and 9 up. Okay. What did I do?
Most that I did.
So I found the slope first on 9. Then I use y minus y1. So y plus 4 equals 6 over 5 x minus 1. Distribute there. Bring this up.
Why do you have your point slope from?
I was just using it to, I'll solve it now.
Which I didn't use point slope form, but still that's correct.
Okay.
How do you have 6 for the intercept for 8? The y-intercept?
Plus positive 6 is the y-intercept on that. We didn't have enough information to get the y-intercept just by looking at it. Okay, so I have to do this math.
How did you do the 6? I don't know.
All right, which one are you looking at? You said
Number 8. I was just wondering
how did I get the 6? Okay, so I distributed here. So I got negative 1 half x, and negative half times that is positive 1. And then I add the 5 over. Right? So, problem number 8, I plugged into point slope. I distributed this over. So negative 1 half times x is negative 1 half x. Negative 1 half times 2, negative times negative is positive. 1 half times 2 is 1. And then I add the 5 over here, so that's what gives me the 6. So y equals negative half x plus 6. So 0, 6 would be our y-intercept on this problem. Problem number 9, I had to find the slope. So I'm just plugging into the slope equation. So 2 minus 4 is positive 6. 6 minus 1 is 5. So I get a slope of 6 over 5. I used my point slope equation and took one of my points. This was a negative 4, so that's why it's positive 4. This was a positive 1, that's why it's negative. If I distribute over the parentheses, it yields over here, so I get 6 over 5 minus 6/5, and then I subtract 4. When I subtract 4, it looks like this, so -6 minus 20 over 5. That's just me doing my arithmetic of adding and subtracting fractions. So I come up with y equals 6 over 5x minus 26 over 5. 0 comma negative 26/5, or 0 comma negative 5 and 1/5 would be my y-intercept on that problem.
I have a question.
Yeah.
So with where do you get the 4 in y plus 4 equals 6?
So this was in a point slope. So I had a point 1 comma negative 4, and I plugged into my point slope.
Maybe y minus.
Does that make sense?
Yeah.
Sweet. Are we okay with the first page, page 110? Okay, you know what to look for on the test. Make sure you're good with that, or the quiz. All right, may I move to the second page, page 111?
Yes.
Okay? So why don't you all try 10 and 11. It says write the equation and put it in point slope form. Okay? We will have on the test written point slope form for you, so they will be there. Okay, so why don't you go ahead?
Equation one.
What's that? It's the slope equation wall. Ten and 11 are done. You're just plugging them directly into your point slope equation. Should you have y minus 0? Could you have y plus 0? Absolutely. Do you have to have the 0 there? It's not necessary. So 10 and 11 should be pretty quick go-tos. And it's again just using your point slope form, which is this. And the goofy thing, let's see, 10 and 11, we already had just 1 point given. If you have 2 points given, it doesn't matter which point you plug in.
Let's look at this here.
All right, number 12 says use the 2 points, write a line in point slope form, and then rewrite it in slope-intercept form. So 12 has kind of a lot to it. So the first thing I'm going to do is I'm going to find the slope. So I have to pick negative 4 plus 5 is 1 over that. So I get a slope of negative 1 over 2. Is that okay? It doesn't matter which point you use. I'll do it both ways. So I'll use 3 comma 5, negative 5, or I'll use 1 comma negative 4. Doesn't matter, so point slope form. And then if I distribute this over, is that okay so far? Solve it for y, so subtract 5 from both sides. Let's see, that would be 10 over 2, which that's going to give me negative 7 over 2.
Negative 1/2.
Negative 1/2 x minus 7 over 2. And if I use my other value here, so that's going to give me y plus 4 equals negative 1/2 x minus 1. Distribute here.
Will we see number 12 on the test?
Absolutely. So that's going to switch to that, which is negative 7 over 2. So please note that you You get the exact same answer. Doesn't matter which point you use on it.
So we don't need to do both.
Nope. I'm just showing you it so you can.
So,
Sometimes one of the points will be a nicer point to plug in, especially if you have a 0 in it. Any questions up to number 12? All right, so let's see, 13, 14, 15, and 16. Okay, so there's going to be problems very similar to how those are. So let's take a look at number 13 real quick. So they want to know, are those two parallel to each other? So what is the slope of the one equation? What's the slope on number 13 of the first equation?
negative 1/2.
Negative 1/2. What is the slope on the second equation?
1/2.
1/2. R is negative 1/2 and is positive 1/2 the exact same number? No. So are these parallel? No. So not parallel. Not parallel due to different slope. Different slopes, I guess you could say. Does that seem like a good enough reason? The two longer lines mean parallel. Not parallel due to different slopes. Negative 1/2 and positive 1/2. They might be the same fraction, but one's positive, one's negative. Yeah.
When writing the y for the parallel or not parallel, do you need to go in depth into what you're saying?
How in depth did I just go right there?
Easy.
Yeah. Not parallel due to different slopes. Hopefully you have a greater understanding of slope, which you should.
Right.
Some greater. All right, 14. Number 14. The first equation has a slope of 3, but the second equation is this. Can I determine the slope just by looking at that?
No.
What do I have to solve for?
X.
I need to get y by itself. So I'm going to subtract 6x from both sides. Those cancel. You agree with that so far? And then what's the last step? Divide everything by negative 2. Okay, those cancel. Y equals 3x minus 6. So what is this slope?
3x.
No, it's 3. Do not put the x with it. All right. Is this slope and this slope the same? Are the lines parallel? So yes, parallel, same slope. That's a totally good reason. Okay, again, these two longer lines mean they're parallel. You will see very similar types of problems to that. Okay, where you might have to work out, so get it into y equals mx plus b form in order to get there. (15) and 16, we want to look to see if they are perpendicular to each other. So that means that their slopes are flip over fractions, opposite sign. Agreed? So number 15, I have a slope of the first one being negative 3 over 5. And I have a slope of the other one being what? 5 over 3. Are they flip over fractions? Yes. Is one positive, one negative?
Yes.
So true. They are perpendicular due to, you could label it like this. You have m and negative 1 over m. Or you could just say they're opposite sign reciprocals, or a whole plethora of things. In fact, if you were to multiply negative 3/5 and 5 over 3 together, if you multiply the slopes together, perpendicular lines always result in negative 1 being the answer if you reduce the fraction, so you get negative 15 over 15. And then number 16. I have the slope of one being 6. I have the slope of the other being 6. Are these perpendicular? No. These are not perpendicular. They are not perpendicular. Being they are parallel. Same slope, absolutely. Yep, I like it. I'm not looking for the most in-depth reason, just that you showed something. I mean, if you just put true, you're going to miss the reason point. So that would probably, those would each probably be 2-point problems. So the true or the false, and then indicating the reason why is your other point. All right, we're done through all the way through page 111. Is everyone okay? Number 17. They gave us this. Looks like I can identify that as 0, -3. Agreed? And then also know that point right there. Looks like -1, -1, or -1, 1. Okay, so I could do this a number of ways on this problem. I could count up and over, and that would give me my slope, or I could use my slope equation. It doesn't really matter. So I'm just going to count up. Looks like it goes up 2, right 1. So I get a slope of 2. Agree? Write the equation of the line shown. So we can write our equation as this or this. Okay, I would probably choose to use this, being that I know my y-intercept is that. As on 17, page 112. Okay, I'd probably stick with that. You could plug into this, but I don't think in this case it just says write an equation. And being we know the y-intercept, stick with the y-intercept and plug the slope in. Last problem, number 18, and I have plenty of time to go over it, and then we can go over any individual questions throughout this page or the other pages, okay? May I start number 18? Okay, so it talks about a bank account has $300 in it. I start saving each week. In 3 weeks, I have $375 in it. What is the x variable? What is the y variable? Write an equation that models how much money is in my bank account. Explain what the slope means. Explain what the y-intercept means. How much money do I have after 1 year, which would be 52 weeks? So, I have a certain amount of money in my bank account. So, I would say this is weeks, and this is money. So, what is the x variable? Weeks. What is the y variable? Money. Agree? Okay? Just by looking at this problem, I think I could probably start deciphering what the slope is, but when I first start at 0 weeks, I have $300 in my account, and then I have, after 3 weeks, I have $375 in it. Yeah. So it's pretty easy to identify real quick what the slope is. The slope, I'm putting $25 every weekend. Okay? So I could just keep it as 25. So then, do I know my y-intercept at this point? What is it? Yeah, 300. So my b value is equal to 300. Okay, so my linear equation, I'm just going to use this because I already know my y-intercept and I know my slope. So that's my good linear equation. Okay, so my x variable is weeks, my y variable is money. Write an equation to show how much money I have in my bank account. Well, we were able to figure out the slope pretty easily just looking at this, saying, hey, I'm putting $25 a week away in my checking account. Okay? Explain what does the y-intercept mean. So what does the y-intercept mean? This is what my... Yeah, we started with 300. So the y-intercept, we started with $300. Okay? how much money will I have after doing this for 1 year, which is 52 weeks? So where do you think I should plug 52 weeks? Should I plug 52 weeks in for Y, or should I plug 52 weeks in, or 52 in for X? Look at what we have labeled up there. So where does the 52 go? In the X, okay? So I'm going to plug that 52 in right there. So 25 times 52 plus 300. Did you get the whole thing?
Well, no. Oh.
So 25 times 52, and then whatever added 300 added to that. 1,600? Okay, so after 1 year of this savings account, by you putting $25 a week in, round you up to $1,600, $1,600. Okay, and that's not accounting for interest or anything like that, but that would just be like, this would be probably not necessarily a savings account. This might be like you have that jar at home. You just $25 every week you put money in. All right. So we have a few minutes left. Is there anything from page 110, 111, 112 that we just went over that you want a little better explanation on? Yeah.
Can you go back to 17?
17, yeah. And we knew this point, 0, -3, and we knew -1, 1 when I looked at it. And so I just counted up 2, right 1 to get my slope.
Okay.
And then this right here is my B value, the 0, -3. So then I can just plug straight in.
Okay.
Any other that you'd like to go over from 110, 111, 112? That's just what we did today. And then page 108, yeah, 18. Do what? Let's see. A. So this is A. This is B. This is C. What does the slope mean? So letter D. The slope means put $25 per week into the savings account. E, what does the Y-intercept mean? That's E. We started with $300, and then here's F. I would say I would study what I feel that you all should look at is page 108 through 112. Those were reviews that we worked on. I worked on page 108, 109. We worked on this on the Friday before break. The video is up. Okay, so if you want to review watching that video, that might work. And then page 110 through 112, the video will be up here in about an hour. So I would just study those 2 pages. You're locked with it. You will have a quiz tomorrow. Also, if you are checking out that calculator, guys and girls, get your form submitted to the Math Science Resource Room and get that calculator. Yeah. I'm holding off. They're not really helpful. Yeah.
I have some.
Oh, yeah, I'll take it. So when are you going to give it to us?
I don't know. Hey, Catherine.